Hello. Today what we're going to do is we're going to take a look at some top-down movement activities. We're going to do a WSAD movement and a click to move mouse movement. So we'll see you right back here in just a second. Okay, so what we've got happening on screen is I've already pre-assembled the project so that I can go over what I did here to make the best use of time. So what I started with was I made several scenes here. I started by making a start screen scene, and all I did here was set up a control node, add 2 buttons and a camera, and so then each of those buttons has a script attached to it, and those scripts have the signal over here on button pressed, and that then brings you into the associated scene. So this move with WSAD keyboard, that will bring you into test level 2, and move with left mouse clicks, that will bring you into test level 1. So if I come over here to the scripts, and all I've got set up in the scripts is simply extends the button, preload my test scene just as a reference, then on button pressed, get tree, change scene to file. Now this is important to let you know that in previous versions you didn't have to say to file. You could just say change scene. I think that was like 3.2. But with the newer Godot, you have to have to file in there. So I actually fought with that a little bit because I'd been used to using an older version for my change scene. But I'm now using I'm using 4.3 here for my official lessons, but I'm using 4.7 dev or 4.6 dev. Anyway, then that points to the test level. And then I've done the same thing on my WSAD button. On button pressed, it goes to test level 2. So there's no real difference between those two except the scene that they're loading on button pressed. So pretty simple. I'll just show you how that looks. So I've also got this camera zoomed in. So then I hover over, and it changes color here, and then it'll load into the next scenes. So how I've got that changing color is I've just gone down here to my theme overrides. So on the button, if you're not familiar with it, on the button itself, you select the button. I'll just select it. Then you come in here, put in the text you want. You can do a whole bunch of customization. You can add special icons. You can do whatever you want. However, I just kept it simple because it's just to move to the different screens. But then I wanted to make sure that when the mouse is hovering over the button, you can see you're hovering over it to click it. So I've done a theme override, color, font, hover over color, and I've set it to this green color. And I've done that for both buttons. So as you see again, if I hover over, and if I hover over. So pretty simple. So the next thing that I've done is I set up my player body. So I have 2 player bodies and I have 2 scenes. So I'll go over the scenes first because they're the easiest. So test level 1 is pretty simple here. All I've done is I've set up sprite 2D, like a parent node, then a sprite 2D node, and then I just simply and then in the sprite 2D node, all I have set up here is this grid that I made, which is I've made 2 of them and I've just got different colors on them, and it's just to give you some square banding to see to actually reference the screen size, which is 1024 by 768, and also just to have the banded patterns, like almost like a gradient movement, like a test screen on the old school TVs where you had the bars up and down. So same sort of idea. So when the player moves, you can actually see the players moving rather than just a blank gray. I use test bars or test patterns quite often, and I'll just set them up with different measurements and increments. Here I didn't put any specifics in for the banding, it's just to show movement, but I did set up the master screen size because often you're going to want to know exactly how big an area is for when you're laying down your tiles or laying out your 2D images or your sprites or parallax layers, etc., etc. You're going to want a reference of some sort, so that's why this is a 1024 by 768. It's just a good pattern to get into when you're testing things out. So that's pretty simple. And then test level 2, same thing, just different color pattern to know that it's actually a different level that you've loaded into. Okay. Then over here for the player body, so those are pretty simple levels to move around in, nothing special at all. Player body 1. Now what this is I've basically just set up a character body 2D, renamed it, then added an animated sprite, renamed it to animated player 1, and then added a collider to it just out of best practice. I did not actually need a collider to demonstrate what I'm showing you today, but I always like to attach a collider to my player body because you're going to build on that. So you might as well have that scene set up with the 2D collider built on there. So collider shape 2D, and then I've just set it as this capsule shape right here. I can just hide that so you can see that's what that is. I have a little cleanup to do on my sprite sheet. It's not perfect, but we're zoomed way in more than the player will be. This is just for demonstration purposes. This will also be a player that we use in upcoming character for like survival gathering, maybe RTS characters, maybe RPG. It's just a good basic empty sprite to use. And then I've attached a camera 2D on top of that. And then set that camera 2D to be 1.5 zoom out. And there's also a script attached. Now that script, if I come over here, that script is just the player movement script. And this is the one for the mouse button. So what this does is it basically sets up go to the top here, comes at the bottom. So it extends the character body 2D because it's attached to the top level. Sets a constant speed of 300. Sets a target to null variable, and we're going to use that variable to set our location of our mouse click. Then the function, we're declaring our function here of an input event, and that if event is action pressed, so if a button is pressed, set target. So now this is important. This set target here, we're going to come back to that in just a minute. Target equals get global mouse position, which is a built-in GD script command to get the location of where your mouse is sitting cursor wise. But this set target, we have to set that up in the project settings under the input map. I'm going to turn off show built-ins. And all we've done is we've created this new one called set target, and we set it to be the left mouse button. Okay. Now we could also set that to be, well, you could do a gamepad, you could do a point reference if you're building this for mobile or something, and you want to touch the screen to move the player around in different locations. You could set that up for the same thing. But anyway, so we've set that up as a custom input device. And it is called set target, so it references that and it ties it to the get global mouse position. Then down here we set up the function physics process. If target equals null, variable direction equals position of target. So basically that just says if it equals this, because that's what it's set to start with. But then it says get the mouse position and set it to the target. Set the so the direction is equal to target. The distance is equal to the target. So basically, it'll calculate the distance between where the player is now and where you've clicked on the screen. Same with the direction. So it'll automatically find those as a built-in positioner. Then if distance is greater than 5, set the velocity direction normalized times the speed. So basically it just says move towards that target, move towards the location we've established here. Then move and collide, and now we use move and collide instead of move and slide, because we also want to check for collisions along the way. So if it's move and slide, it'll has a good opportunity to mess up and not interact well with collisions as it goes from point A to point B where you clicked. However, move and collide will look for collisions along the way. That's about the easiest way to say that. And it's also going to do that movement based on velocity times delta. And of course, delta, again, I've said this in my previous videos, delta is a normalizer over a second. So if you've got a really fast computer, it slows it down. If you've got a really slow computer, it speeds it up and skips steps. Delta, just think of it as a normalizer over the course of a second. And then update animation equals direction. Okay, so then now we come down here, else. So if this doesn't happen, if we don't click anywhere on the map, it's going to set the target to nil, and it's going to set the velocity to vector 2, 0. Vector 2 again is just drawing in a 2D space. Vector 3 is drawing in a 3D space. So we're setting that to nothing. So basically don't move from your current location. Then here, animated player 1 equals play player idle animation. So basically we just want you to be idle if you're not moving. Else, if you are moving, play idle by default. So that's actually this. So I got this in here twice, and I did this because I wasn't sure this was going to work by itself. So I added the target equal to establish the target as being null again. So you may not need both of these. You could try commenting out one or the other. I'd probably be fine with just this set in here. But I had both in just because I was troubleshooting to make it work, and I was getting tired and I didn't know which one actually rectified my problem. So I think it was this one here, adding the target equals null in. But this might have just worked by itself too. That's something you can test on your own. Not super important. Just be aware that one of those might be a duplicate. Then function update animation, direction vector 2. If direction.x is greater than ABS direction.y, if direction x equals 0, switch to player walk right, else switch to player.left. Then down here we're going to do the same thing for the y, player down, player up. So that's a pretty simplistic way of doing it. And I'm sorry that I've got so many indents in here to work, but it's like function nested in an if function nested in an if function, and then another return on an else function, then another if function. So sometimes you get a lot of tabs in order to make it work. I probably could have simplified that more, but that's what I got, and so that makes that work. So that basically makes it so when I click on the mouse, play, move with left mouse clicks, faces up if my mouse is clicking up, faces down if my mouse is clicking down, left if my mouse is left, right if my mouse is right, and then returns to idle at every step of the way. Now you could do that more complicated, and you could put in like a back facing idle if you're facing up or left or right, but I just kept it simple to show you a basic click to move script. So this is one of the things a lot of people have a hard time with in game engines, is getting a move script. Now you have to pardon my little dots in here. I need to clean up on my template. I was kind of in a hurry to set this character up for this example today, but that's how that one works. So that's the left click, and we'll go over here to the next one. So now next is player 2, and player 2 is set up to work on the second test level that we already went over. However, and it's exact same as player 1, except it has a different script attached to it. That script is a simple variation, a modified version of the script you already used in the platformer script. We've just removed gravity and we've added extra functionality to it. So export speed, float 200. Now we could have put that as an integer 200, but I just left it as float just to show you that it doesn't really matter if you do float or integer for these things. The other thing about float is it'll be a little smoother transitioning on the speed in some instances. Not necessarily in this instance. You're not modifying your speed or anything. However, there may be times where you want it less jaggy as it goes from one thing to another, and the float can allow for a smoother transition between. I haven't really noticed it, but I've read that, so I'm giving you the speech. So function process delta, set up a variable direction vector2.0. So it's basically we're setting up our direction here as a variable. Then down here we're getting the input from the keyboard and setting up the animations. So the UI right, UI left, UI down, UI up. And what we did do here was in the project settings, turn these back on again. If we come down here to UI right, you can see where I've hit this add button, and then I've added the D key here. So all I've done is add the WSAD keys. I've left the joypad buttons in place, and I've left the right arrow buttons in place. No reason to take those out for this project. You could use either or, but I just wanted to show you. So this will set up joypad movement and WSAD movement. Now in theory, you could also attach this script as an alternate script to the player with a startup script, so that when you choose from your start screen, you could choose use joystick or use joystick or mouse or keyboard, use direction pad or use WSAD keys. You could have it set up so that it swaps out which script for the player, or just swaps out the player in the scene. And then you've got the alternate script attached to it as well. So you do that in a game settings menu. I'm not showing you how to do this here. I'll probably do that later on once we get a few more things set up and playing around. However, I just wanted to let you know you can do that. So back to player body 2, script. So here, if you UI right, so you got your WSAD, and you've got your change the direction to move it, vector 2 to the right, vector 2 to the left, vector 2 down, vector 2 up, and those are built-in commands in Godot. Those are set. Those are set automatically behind the scenes. You don't have to declare right, left, down, or up. You just tell it you're going to go in this direction with the plus equals 2. So basically, it's just checking: are you moving this way? Okay, if I'm moving that way, I'm going to be playing. If this key is down, I'm going to be playing this animation, and I'm going to move this way. And then over here, it's just normalize the direction and move the character. Again, this is vector speed 0, and it's a move and slide. Velocity equals the direction equals the direction normalized, and again, normalization is normalized over delta. This time I'm normalizing over speed, not delta, but you can normalize and put delta in the brackets here. And then I had put if the vector equals 0, the animated player 1 play idle here. We actually don't need that at all. I've just added another else down here, and that made it happen. So basically, if you're not doing any of this, you're just going to move here in the idle movement because you're moving 0. So I'll show you what that looks like. Move with left mouse clicks, we already showed you. Move with WSAD buttons. So A, back to idle again. S is down, back to idle again. W is up, back to idle again. D is over, back to idle again. And if you have a gamepad plugged in, gamepad will move you the same way. So, and so will the arrow keys here. I'm just doing the arrow keys now because they were already built in. So there you have it. There's two different methods of moving moving via keyboard WSAD or arrow keys, or joypad on the joystick, and or moving towards your mouse clicks, like some of the older RPG games did. And I know that is a popular thing that a lot of people ask for, so I wanted to make sure to show you both methods for top-down movement. And I'm not sure exactly what I'm going to do in the next video, so it's going to be a surprise for both of us when I get there. Have a great day. And we'll see you in the next one.